Welcome back from our short little break. Today we're going to talk about the features of a parabola. Here are some reminders and announcements. If you ever have questions, please email me at jlockhart@gmail.com. It's not too late to turn in late work for quarter 3 or 4. Make sure you have out a pencil and paper and be ready to take notes and try the You Try problems as we go. Be sure to use your school email address. If you do not know how to log into your school email address, please email me and I can help you get it figured out. From this point forward, the Google Forms IP will be locked unless you log in with your school email. There is never a reason to guess. Leave blanks or write IDK in an answer blank. Email me or attend office hours to get your questions answered. For mediation, quarter 4 ends on May 21st. If you are passing with a C or better by then, you are done. If you are not, you will need to continue working for 2 more weeks, so let's get these assignments handed in. Don't forget, if you have a 60% or better, you will be eligible for mediation at the end of the semester, and most of you can hit that mark by just handing in missing work. In order to help you boost your grade, we created a bonus point project. So we will be offering you this project for the month of May. This project will be worth 20 points and will involve you choosing from a list of specific skills and creating a presentation of your choice on that skill. 20 points is equivalent to 2 missing e-learning assignments, so it could have a big impact on your grade. Remember, this project is optional, but it will serve as extra credit. We have designed this project to be possible for every student to do and should be a boost to your grade if you make an effort to meet the requirements. The projects will be due by midnight on midnight on Friday, May 22nd, which is the day after the last day of school, which is May 21st. The expectations and the rubric for this project can be found on my haiku page. Okay, so let's get into our lesson. What does a parabola look like? Here are some examples of parabolas in real life. So we have the McDonald's arches, St. Louis arch, some roller coasters, some aqueducts, and the shape that a football makes when it's being thrown. So the graph of any quadratic equation that is in standard form will graph a parabola. Pause the video. Which of the below equations are in standard form? If you do not know, then you should stop here, go back to haiku, and rewatch the videos on solving by factoring and solving by quadratic formula from April 15th and 16th and April 22nd and 23rd. The only equation here that is in standard form would be B. Remember, standard form follows ax squared plus bx plus c equals 0. Since A, C, and D from the previous problem were not in standard form, let's put them in standard form. Go ahead and pause the video and try these now. If you don't know how, then you should stop here, go back to haiku, and rewatch the videos on solving by factoring and solving by quadratic formula from April 15th and 16th and April 22nd and 23rd. So for this one, we'll just need to subtract 9 from both sides first. And we'll get 5x squared plus 7x minus 12 equals 0. This one would be negative 2x squared plus 0x minus 5 equals 0. We have to add in that term, that b term, because we only had an a and c term. And for this one, we'd add 5x to both sides. And we need to write the numbers in order. So negative 3x squared plus 5x plus 9 equals 0. So remember, you cannot graph a parabola until your quadratic equation is in standard form. Now let's talk about the direction of a parabola. A parabola can either open up like a cup or down like a frown. Okay? The vertex of a parabola is either a maximum or a minimum point. If the parabola opens up like a cup, then the vertex is going to be the minimum point. Okay, and that's what we see down here. That vertex is the lowest point on that graph that opens up like a cup. If the parabola opens down like a frown, then the vertex is the maximum point, because it is the highest point on the parabola. And an example of that is here. So that black dot is that vertex, which is that highest point of the graph that opens down like a frown. Go ahead and pause the video and try to answer the question. Does the parabola have a maximum or minimum point? This parabola has a minimum point. Okay, and that minimum point is right down here at the bottom of this blue graph. Okay, so that means this graph has a minimum. Try this one. Go ahead and pause the video and give it a try. Does the parabola have a maximum or minimum point? This parabola has a maximum point. So what happens as we move away from the vertex? Okay, it's important to note that parabolas continue on either side to positive infinity or negative infinity as we move away from the vertex. They don't just stop because we run out of room on the graph. Okay, so these graphs will go on and on infinitely. Let's talk about lines of symmetry. One property that a parabola has is that it's symmetrical along a vertical axis. If we remember, vertical is straight up and down, and horizontal is from left to right. So if we fold the parabola in half vertically, then the two sides will be exactly the same. Pause the video now and try to determine which of the below shapes are symmetrical along a vertical axis. One property that a parabola has, once again, is that it's symmetrical along a vertical axis. If we fold the parabola in half vertically, then the two sides will be exactly the same. So you were supposed to look at these 5 shapes and decide which one had a symmetrical sides when folded across the line of symmetry. So the yellow, green, and purple shapes are symmetrical along their vertical axis. The red and blue are not. If we fold them in half, the sides would not match. More about the axis of symmetry. The axis of symmetry of a parabola is a vertical line that cuts the parabola in half. Okay, so let's apply this to our parabolas now. The vertex always falls on the axis of symmetry. Our key word for today, our code word, is Marcus. There you go, Marcus. Okay, so the axis of symmetry of a parabola is a vertical line that cuts the parabola in half. The vertex always falls on the axis of symmetry. Since vertical lines are always written in the form we can easily find the equation for the axis of symmetry by looking at the graph. Since the vertex falls on the line of symmetry, then the vertex will always be the point xy, where x is the axis of symmetry. Okay, so let's define this here parabola. This parabola opens up. The vertex is going to be down here at this point. So we have to find the x and y value for that point. So it's going to be 1, comma, and then the y value, 4. Negative 4. Okay. Its axis of symmetry is the line x equals, so it's straight down here. It's going to always be the same x value as our vertex, so it will be x equals 1. So the vertex point is going to be 1, negative 4. I apologize. Up here, I was supposed to write something different. The vertex here is a minimum. That's what I want you to put in that space. Okay, so this graph opens up like a cup. The vertex at the very bottom of the graph is a minimum point. Its axis of symmetry is the line that cuts our parabola in half. So it's going to be at that value 1, which is in the middle. And the vertex is going to be 1, so it's always the same number as the axis of symmetry, and then you have to include the y value for the point, which is negative 4 in this case. Okay, I want you to try and answer these questions for this graph here, okay? So this parabola opens up. The vertex is a minimum point. It's at the very bottom. The axis of symmetry is the same value as the x value as the vertex. So the vertex is down here, and that x value is 3. So the axis of symmetry is 3, and the vertex point is going to be 3, the same x value as the axis of symmetry, and then the y value is 1. Okay. Try this one. The parabola opens down. The vertex is a maximum this time. It's the highest point of the graph. The axis of symmetry is that x value that goes through that vertex, so negative 1. And our vertex is going to be negative 1. Okay. And the y value is 4. Okay, let's try this one. So the parabola opens up in this case. The vertex is going to be a minimum point because it's the lowest point on the graph. The axis of symmetry, so this is the center, and that x value is 0. So the vertex point is going to be 0, and the y value is also 0, right there. So 0, 0 is our vertex. Okay, let's talk about the zeros of a parabola. The zeros of a parabola are the points where the parabola crosses the x-axis. Remember, you already know how to find these with the equation. They are what we find when we solve by factoring or solve using the quadratic formula. Okay, so let's look at this graph on the left and decide how many zeros and what those zeros are. So there are 2 zeros for this parabola because the blue line crosses the x-axis twice. So here and also here. So the zeros are going to be x equals negative 3 and x equals 1. For this graph here, there is only 1 0 for the parabola because the red line crosses the x-axis once. And that spot would be right here. Okay, so the 0 is x equals 0. If there is only 1 0, then the 0 will always be the same as the vertex. Okay, So the axis of symmetry here would be 0, and your vertex would be 0, 0. For this one, there are no zeros for this parabola because the curve does not cross the x-axis at all. So this is what happens when you cannot solve an equation by factoring or by using the quadratic formula. Okay, so next time we will learn more about zeros and how to use them to graph a parabola. Go ahead and pause the video, and for each of the graphs below, identify the actual values of 0. So here, our 0 is the only place that the parabola crosses the x-axis, so x equals 3. Here, it crosses at -3 and 1, so x equals -3 and x equals 1. And here, my x-axis is down here, and it never touches, so we do not have any zeros for this last parabola. So I wanted to show you how to write a 0 as a point. So not only do we identify that the 0 here, the only place where it touches the x-axis in our first situation, is at 3. So whenever we want to write it as a point, we write 3 and then 0. 0 would always be our second value for the 0. Okay. All right, great job. Please return to the haiku page and complete the assignment on features of a parabola for today. Don't forget to take a look at the rubric and expectations for the project to help boost your grade. See y'all later.